chapter is on electricity, and the electric force is responsible for a whole lot more than you are probably aware of. I mean, obviously the electric force makes electricity flow so that when you plug something into a wall outlet, you're going to have an electric current available to use to power whatever it is you tried to plug in. It also will hold the electrons into an atom. It makes lightning. It attracts the north pole of a magnet to the south pole of another magnet. It causes your refrigerator magnets to stick to the refrigerator because actually electricity and magnetism are just two different aspects of the same force. They're very, very closely related to each other. It causes your compass needle to always point north if you're using a compass outside. So the electric force, again, is responsible for a whole lot of different things that probably you may not initially be aware of. We're going to discuss the structure of an atom in great detail in an upcoming chapter, but I do want to go over just a couple of the basics of it because we're going to be talking about things called electrons. I want to make sure you understand what those are. An atom has three main particles that make it up. There are some other smaller ones as well, but there are three main ones. And there's a negatively charged particle, which is called an electron, and it circulates or orbits kind of around the outside of the atom. On the inside of the atom, in the nucleus of the atom, you've got protons, which are positively charged, and you have neutrons, which don't have any charge at all. So you've got your positive charge and your neutral charge in the middle of the atom, surrounded by negatively charged electrons. So since the electrons are on the outside of the atom, it's relatively easy to pull them off, and it's also relatively easy for an atom to get electrons from another atom and add it to itself. So atoms are very much capable of gaining and losing electrons quite often. And so when we talk about atoms, or when we talk about items that are gaining or losing charge, it's the electrons that we're specifically talking about. So in the lab that you just did, when you took the balloon and you rubbed it in your hair had some stray electrons in it, and so the balloon picked those electrons up, and the electrons got stuck to the balloon then. So then when you did that to two balloons, and then you tried to bring the balloons close to one another, you should have noticed that the balloons tried to push each other apart. Well, both of them had extra electrons, so they both had extra negative charge on them. And so what that tells us is that when we bring two like charges next to each other, they repel each other. And so we've got basically four rules of electric force that we're going to go over today, and that's the first one. Like charges are going to repel each other. So whether you have two positive charges or whether you have two negative charges, if they're both the same, they're going to repel each other. Now in the next part of your lab, what you did is you took a piece of tape and you stuck it to the table. And then when you ripped it off, some of the electrons got stuck in that sticky residue that was still left on the table. It may not have been much, you may not have been able to tell the table was sticky, but there was still some residue that was there, and there are electrons that were stuck in it. Well, if you lose a negative charge, what that means is that what you then have is a positive charge. So your tape had some positive charge in it. When you took that positive charge and you brought it up next to the negatively charged balloon, you should have seen that they were attracted to one another. They drew each other together. And so that's the second rule of electric force, and that's that opposite charges are going to attract one another. So a positive and a negative are going to be attracted to each other, much like the north and south pole of a magnet will be attracted to each other. The third and fourth rule is going to look very, very familiar to you because we have discussed a very similar rule when we talked about gravitational force. If you remember, we talked about how you have two bodies that both pull on each other with gravity, and how much that gravitational force depends on the mass of the two items, and it depends on how far apart the two items are. We talked about it again when we talked about intensity of light, and we said if you have a light source shining on something else, then the intensity of that light source depends on how strong the light source is, and it depends on how far apart the illuminator and the illuminated object are. Well, if I have two charged particles, they're going to behave in a very similar way that we have already seen with luminous intensity and with gravitational force. So basically, if I have two objects and they both have charge on them, the force is going to be directly proportional to the amount of charge. So the more charge I have, the more force that I have. Secondly, if the further apart that you get the two objects, the less effect that charge is going to have on them. And so just like we said with the gravitational force, if you take the distance that the two objects are apart and you square that distance, then the force is going to go down by that amount. So if the distance becomes 4 times as great, then if you square that, that becomes 16. So the force is a 16th of what it was before. If you take the distance and you double it, then if you square 2, that's 4. So the force becomes a 4th of what it was before. Okay. So if you're still a little fuzzy on that, you can go back and review those when we talked about both gravitational force and intensity, because the rules are exactly the same. So we're going to be doing exactly that same type of thing here. So again, these two second rules here, with the force being directly proportional to amount of charge and inversely proportional to the square of the distance between them, along with like charges repelling and opposite charges attracting. And those will be all the things you need to know for right now as far as electric force.